Watching this video, you're watching my lesson on pulleys. This is the second half of this lesson that will focus on a different simple machine. In this lesson, we'll be focusing on pulleys. So I'd like to start off with, what is a pulley? Well, in this picture, you can see a simple pulley right here, right? And basically, a pulley is just a wheel that can support a rope. And so you can see this is a wheel, but it's got that inward groove where you can put a rope around and try and lift things. So pulleys are used to lift heavier objects. There are two main types of pulleys. You got your fixed pulley and you got your movable pulley. A fixed pulley, fixed means to stay put. So a fixed pulley is a pulley that can't be moved, right? So in this case, we see that this pulley is basically screwed to the ceiling. And so this pulley is stuck in that spot, and so we call it a fixed pulley. In this case, we have a movable pulley. This is a movable pulley because you can see that this pulley is not attached to anything. It's not attached to the ceiling. It's not attached to anything other than the weight, and the weight can be removed. So this pulley can be moved anywhere. And so we call this a movable pulley because this pulley can be inserted or removed as you see fit. So let's start with the first one, the fixed pulley. These are pulleys that are attached to a ceiling or wall, right? And you can see in this picture we have our load or whatever object we're trying to lift, and the rope goes up around the wheel of the pulley and out. And so the effort comes from pulling on this rope to lift the load. Now, what do you think the mechanical advantage would be? If you were to pull on this rope, what would the mechanical advantage of this pulley be? Well, it would be surprising to note, but the mechanical advantage of a fixed pulley is 1. So if you only have one fixed pulley, then its mechanical advantage is 1. So what does that mean? Well, if you remember from our previous lessons, a mechanical advantage shows how effective the machine is at multiplying the force you put in. So if you had a mechanical advantage of 2 or 3, what that means is the machine multiplies the force you put in by 2 or 3. Well, if you have a mechanical advantage of 1, doesn't that mean that the force you put in is the same as the machine puts out? Yeah. So what the heck's the point? Why would you have a fixed pulley? Why even have one? If the mechanical advantage is 1, it's just as hard to pull this rope and lift the load than it is to just lift the load. Well, the reason why a fixed pulley is used is because it allows you to change the direction of the force, right? So an example of a fixed pulley you see every day is a flagpole, right? To raise a flag, rather than trying to lift the flag up, you could pull down on the rope, which will force the flag up. So you're changing the direction of the force. Your force is going down, but because you have that fixed pulley, the pulley changes the direction of your force to go up. So it's easier to pull down on something than to lift something, right? You're able to pull down using the force of gravity, your weight, which can help you make it easier to lift the load. So a mechanical advantage of 1 allows you to change the direction of force. Again, class 1 levers can also have a mechanical advantage of 1. And the point of that is to change the direction of the force. It doesn't necessarily make it that much easier, but it allows you to change the direction of force. Then we have a movable pulley. A movable pulley is one that attaches to the rope. The rope may be attached to the ceiling or wall itself. So what would the mechanical advantage of a movable pulley be? Well, a movable pulley would have the mechanical advantage of 2. Well, what's the difference, other than one being movable and one being fixed? Why is a fixed pulley having a mechanical advantage of 1, while a movable pulley has a mechanical advantage of 2? Well, it all comes down to how the rope is oriented, right? So when you look at a movable pulley, and we have this 100-pound load attached to this movable pulley, the weight is distributed along this rope and along this half of the rope. So because the weight is distributed in 2 different directions, it's cut in half. So this part, where the rope is fixed, is holding on to 50 pounds, while the effort you're pulling on is also holding on to 50 pounds. So you're only having to pull onto 50 pounds, meaning that you are only pulling on half the weight. So that means the mechanical advantage is 2 because a movable pulley divides the weight or the mass of the load you're trying to lift or pull on. So if you have a group of pulleys, this is called a block and tackle. This is called a block and tackle. So how would we get the mechanical advantage of this? Because now we see fixed pulleys and movable pulleys. How would we calculate the mechanical advantage of something called a block and tackle? Well, this is even easier, right? To find the mechanical advantage of any block and tackle, you just count the number of ropes that support the weight. So if we look at this, we have 1, 2, 3, 4, 5. Now a mistake would be to count this rope and say, okay, it has a mechanical advantage of 5. But that's not true because this is the rope you're pulling on. This rope is not supporting the weight of the load. This one is, right? The rope's being pulled from here by the load. The rope's being pulled by here by the load. The rope's being pulled by here by the load. And the rope's being pulled by here from the load. So you have 1, 2, 3, 4 spots that the load is being divvied up by. So you would say it has an MA of 4. You don't count this rope because it's not contributing to supporting the weight, right? The rope goes up this way. So when you pull down, you're pulling down on this pulley, not pulling up on the weight. So it's this one, this one, this one, and this one, giving you mechanical advantage of 4. Right? So again, holding the weight, holding the weight, holding the weight, holding the weight, not holding the weight. So, practice. What is the mechanical advantage of each block and tackle? Again, we're pulling on this rope. Okay, we're pulling on this rope. So, the load is down here. So, we have 1, 2. So the mechanical advantage of this one should be 2. Well, 2 to 1 would be the ratio, but you could say 2. 1, 2, 3. The mechanical advantage of 3. Mechanical advantage of 4. Mechanical advantage of 5 because 1, 2, 3, 4. Not including this one. 1, 2, 3, 4, 5. Again, not including this one. So each one of these have their respective mechanical advantage calculated by counting the number of ropes that support the load. All right, so we're going to be doing some more practice in class to hammer in the idea of calculating mechanical advantage of pulleys, finding out how to find the mechanical advantage of movable and fixed pulleys, which again is very easy, and then quickly talking and practicing about gears. Hopefully that was useful, and I'll see you next lesson.